Hey, welcome to Storytelling Animals. I'm your host, Dayton Martindale. It's a green new podcast of climate ecology and animal justice. Some of the animals we're going to be talking about today are mammals. That's you, me, mice and rats, monkeys. You know what mammals are. So the author that I will be interviewing today is Steve Brusatte. He is a paleontologist. He is the author most recently of The Rise and Reign of the Mammals, A New History from the Shadow of the Dinosaurs to Us. That book just came out. It's really good. He previously wrote The Rise and Fall of the Dinosaurs, A New History of the Lost World. He's also the paleontology consultant for the Jurassic World movies. So the new one just came out, Jurassic World Dominion, and we're going to talk about that as well. There's, I think, a really fascinating story to tell in his book of how mammals have a very long history, how we've endured mass extinctions and changing temperatures before, how that's been difficult in some ways, but how we've been resilient in other ways, and how some of that is useful and relevant to know as we look forward. If you enjoy this podcast, please consider signing up for my free weekly newsletter. The link is in the episode description. Basically, each week I'll send out, the latest episode of the podcast, some updates on the podcast and our book club, as well as a link to the best thing I read each week. So isn't that exciting? Speaking of book club, our next meeting is in just a week to discuss Entangled Life by Merlin Sheldrake. I just started it, and I'm already having my mind blown by facts about fungi and how the world of life is so interconnected and more complicated than we think. And then next month, July 26th, we'll be discussing The Ministry for the Future, a novel about climate change and humanity's response to it by previous podcast guest Kim Stanley Robinson. If you haven't listened to that interview I did with Kim Stanley Robinson, I highly recommend it. It was one of my favorites I've done. And if you haven't read the book, The Ministry for the Future, I recommend checking that out. You can find out more info on how to join the book club at DaytonMartindale.com/book-club. Easy enough. And yeah, if you want to support this podcast and get early access to episodes and other cool perks, I would be greatly appreciative if you support on Patreon. Again, the link to the episode description, patreon.com/storytellingpod. But enough about that. Let's get to mammals. Hi, I'm here with Steve Brusatte, the author of the new book, The Rise and Reign of the Mammals, A New History from the Shadow of the Dinosaurs to Us. Steve, thanks so much for coming on the show.
Yeah, Nick, my pleasure. Really excited to talk mammals with you.
Yes, so am I. So your book is about mammals, but people who are familiar with some of your past writings might know your book, The Rise and Fall of the Dinosaurs, or other dinosaur-related paleontology work you've done. So how did you go from being primarily a dinosaur scientist to a mammal scientist?
I love dinosaurs. I always have, and I always will. I'll continue to study dinosaurs. Really, when I was trained as a paleontologist, I started out as a dinosaur worker. And I've studied the origin of dinosaurs, and I've studied the rise of birds from dinosaurs, and I've studied the extinction of the dinosaurs. And once I reached the extinction of the dinosaurs, I think it was just natural to start wondering, well, then what happened? And that's really what brought me to mammals. And so a lot of my research over the last several years has turned to mammals, especially those mammals that did live right after the dinosaurs, right after the asteroid, the mammals that really set the foundation for today's world. So as a researcher, that's why I've gone towards mammals. As a writer, with this book, what I want to do in this book really is tell the story of us. Mammals are us. Dinosaurs are not us. Dinosaurs are awesome, but they are not us. We are a mammal. There is an incredible evolutionary story. Over 325 million years of evolution has led us to today. So I want to try to convey the excitement of paleontology, how we discovered this story, how we pieced together this story. And also, I want to try to get people to appreciate this long, rich evolutionary legacy that ultimately produced today's mammals. Because mammals today, there's about 6,000 species, familiar pets and dogs and cats and gerbils and so on, charismatic animals, elephants, whales, bats, lions, tigers, 6,000 species. But really, this is just the tip of it all. And all the species today stemmed from ancestors that endured volcanoes and asteroids and mass extinctions and climate changes and ice ages and everything that the Earth could throw at mammals for the last several tens, hundreds of millions of years.
I'm glad you gave that answer because it foreshadows a lot of what I want to ask about, and because, yeah, there's a lot that's interesting about this, and one of this is that the story of mammals begins probably earlier than I thought, and maybe than a lot of people thought. A conception I had from grade school, from second grade, when I was 7 years old, I remember, is just kind of a progression of the vertebrate animals, from fish to amphibians and reptiles to birds to mammals. But actually, birds evolved from reptiles, and the reptile-bird line split off from the mammal line from our ancestors, actually kind of a long time ago. So when did our ancestors split off from the reptile-bird line, and how did that happen?
I think you're right. I think there's a conception that mammals came on the scene very recently, that there was an age of reptiles and an age of dinosaurs, and the dinosaurs died, and then mammals evolved to take their place. And certainly mammals did take the place of dinosaurs in many ecosystems, but mammals have a much deeper history. And the first mammals, true proper mammals, animals with hair and with big brains and that fed their babies milk and so on, the first true proper mammals have the same origin story as the dinosaurs. They go all the way back about 225 million years ago to the Triassic period, back when all the land was gathered together as the supercontinent of Pangaea. But those first mammals had even deeper ancestry. They had ancestors that went back 325 million years all the way to this time back when much of the Earth was a big jungle, and it was hot and it was humid, back during the time when the mammal line split from the reptiles on the great family tree of life. So when that happened, it was really just one new feature of these mammal ancestors that set them up for success. And this was, they had a single opening behind the eye socket for big jaw muscles. That's what led them to branch off from the rest of the family tree. That's what gave the mammal ancestors their start. 325 million years later, we are the descendants of those animals. And yes, we have that hole behind our eye that has jaw muscles.
Mm-hmm. And I think another conception people might have is that our mammal ancestors remained pretty small until after the dinosaurs. But in fact, before there were either dinosaurs or true mammals, so back in the Permian period, which is right before the Jurassic period, which is before the dinosaurs, the ancestors of mammals were actually pretty big and some of the most, charismatic animals in the landscape of that time. So what were our ancestors doing during the Permian period?
The Permian period was a fascinating time of Earth history, and this was, as you say, before the dinosaurs and before there were true mammals. And the Permian ended in one of the biggest mass extinctions. In fact, it's the biggest mass extinction in Earth history, about 250 million years ago. But before this mass extinction, these early ancestors of mammals, these things that we call synapsids, these are the ones that have that opening behind their eye socket for jaw muscles. These synapsids, they were transcendent. I mean, there were many, many species living all over the world, meat eaters and plant eaters, filling lots of roles in ecosystems. Really, they were the rulers of the Permian world. And if anything, these mammal ancestors looked poised to do even grander and greater things. But then they were struck down by that extinction. But before that extinction, there were famous synapsids, things like Dimetrodon, that animal with the sail on its back that walked on all fours. It looks kind of like a dinosaur. It's often mistaken for a dinosaur. You often see it in dinosaur toy sets and on dinosaur posters, even in a new dinosaur film, Jurassic World Dominion. That a Dimetrodon in there.
I was wondering.
That's not a dinosaur. It's not a reptile. It's actually a synapsid. It is a cousin of ours. It is more closely related to us than to any dinosaur or any lizard. And that exemplifies the sort of mammal antecedents, mammal ancestors that were thriving back in the Permian world. Then that extinction happened. Big volcanoes erupted for many hundreds of thousands, even millions of years, spewed a lot of toxic gases into the atmosphere. There was runaway global warming, and a lot of these synapsids could not cope, and they died out. Maybe 90 or 95% of species died out then. And then in the aftermath, in the Triassic period, the world was primed for renewal. And that's where the few surviving synapsids, some of them then evolved into true mammals. At the same time, though, that some of the reptiles were evolving into dinosaurs.
Yeah, so I want people to keep track. Since mammals' ancestors split off from the reptile lineage, the end Permian mass extinction is the first mass extinction that our ancestors went through, but it will not be the last in this story. So you mentioned in the Triassic is when the first true mammals evolved. What you've mentioned a couple traits before, but what makes something a true mammal?
What makes something a true mammal, first of all, we can think about it as, look at today's world. There's about 6,000 species of mammals, and mammals share several features of their biology, of their anatomy, of their behavior that other animals don't have. So mammals have hair, mammals feed their babies milk, mammals have huge brains, really keen senses of hearing and of smell. Mammals are warm-blooded. Mammals have a whole variety of teeth. We have canines and incisors and premolars and molars, all these different teeth that can chew and process food in different ways. These things, you don't see them. You don't see that package, that combination in anything else. You don't see it in lizards or crocodiles or snakes or frogs or whatever. So those are the things really that make mammals mammals. That's the mammal blueprint. But if we look in the fossil record, there's a dividing line. There's a point in evolution where paleontologists have said, okay, we're going to call this group the true mammals. And what defines that is a new type of jaw joint. It may seem like a trivial thing. It may seem like anatomical minutiae, but it's really important because the ancestors of mammals had lots of bones in their lower jaws. Lots and lots of bones. Dinosaurs had lots of bones in their lower jaws. Reptiles, crocodiles, all these types of animals have lots of bones, but mammals only have a single bone. We only have a single lower jawbone. And so over the course of synapsid evolution, they simplified their jawbones so they could put all their teeth, all their muscles onto one single solid bone. And that allowed these mammal ancestors to bite stronger and chew their food. And it also was involved with, evolving new types of teeth, like the molar teeth and so on. And the characteristic set of one set of baby teeth, one set of adult teeth. So that was involved in drinking milk. All this stuff was evolving together, but the linchpin of it was this new jaw, a single powerful lower jawbone, which meant that those bones that used to be in the lower jaw, all those extra bones of the ancestors, what would happen to them? Well, some of them disappeared, but others were repurposed for a new function. They got small, they moved into the ear, and they became those tiny little ear ossicles, these things that are like the size of a grain of rice in us, the smallest bones in the body. And those former jawbones, now inside the ear, help to amplify sound, to deliver sound from the eardrum to the cochlea and then to the brain. And that led to mammals having just a much, much better sense of hearing than other types of animals. So all of this together, I know it may seem like a lot of anatomy here, a lot of nuance, but when it comes down to it, mammals simplified their jaws so they had one big, powerful, single jawbone they could use to fight hard and chew their food. And that is the feature in the fossil record that when we see fossils of mammals, we say, okay, these things are mammals.
Yeah, I think in particular the story of our jawbones traveling back to become useful in hearing is just a fascinating story of evolution at work in a way that I would never have guessed. I've also become more appreciative of my teeth since reading the book. I just never really thought about how having molars and canines, different types of teeth, was something that made us unique. So yeah, we're in the Triassic. True mammals have evolved among dinosaurs, and one thing that you stress in the book is that the subtitle is From the Shadow of the Dinosaurs to us, but even if we're in the shadow, that doesn't mean that we're just waiting our turn, not doing anything. I keep saying we as if I'm some cool Jurassic mammal doing something, living and thriving in the age of the dinosaurs, but I didn't do anything. But we, the mammal, our ancestors, were doing things. They weren't just, hiding in fear from the dinosaurs. They were also, I think you put it in the book, that as good as dinosaurs were at being big, mammals became just as good at being small and successful.
Exactly. So mammals and dinosaurs, again, they go back to the same time and place, the supercontinent of Pangaea, 225 million years ago, back in the Triassic period. But then those two groups went their separate ways. Dinosaurs were destined for grandeur. Some dinosaurs became bigger than Boeing 737 airplanes. Mammals stayed in the shadows. Mammals stayed small. They needed to survive in a world where dinosaurs were becoming bigger and bigger. So really the dinosaurs kept mammals small. And for 150 million years, more than that actually, mammals and dinosaurs lived together. But no mammal was ever bigger than a badger, as far as we know. No mammal ever bigger than a badger lived with the dinosaurs. But mammals, although they were small, they were innovative. They were evolving. They were diversifying. They were changing, even though they were living underground, in the undergrowth. They were living anonymously, but they were adapting. And so during the time of dinosaurs, you had small mammals that could climb, you had small mammals that could scurry, you had others that could swim, you had others that could dig, you had others that had wings of skin that they used to glide between the trees. So there was all of this innovation in the small bodied niches of the ecosystems. And so while dinosaurs kept mammals small, really mammals did the converse of that. They kept the dinosaurs big because mammals were so good at living at those small sizes that you never saw a T-Rex the size of a mouse or a Triceratops the size of a rat. They just couldn't evolve because mammals controlled the underground at the same time that dinosaurs controlled much of the land.
Yes, so true mammals started evolving in the Triassic period. That period ends with the second mass extinction that mammals and our more immediate ancestors went through. This is the end Triassic extinction, where Pangaea, the supercontinent, the one big continent that made up all the land on Earth at that point, splits apart in the middle. There's massive volcanism. Those lava flows take out animals themselves, and they also spew methane and other greenhouse gases into the atmosphere. It turns out, as we know today, that if you put a lot of greenhouse gases into the atmosphere very quickly, you get rapid warming. Turns out this is not great for the animals who live there, and while some mammals and dinosaurs survive and go on to thrive in the next era, the Jurassic, followed by the Cretaceous, which maybe some of you have heard of Jurassic World or Jurassic Park. But yeah, it's not pretty. And then at the end of the Cretaceous is the third mass extinction that we're covering in this podcast. This is the famous one. We don't have to go into too much detail here because A, you've probably heard of it, an asteroid hit the Earth, and B, we went into the more specific effects of that asteroid in a previous podcast episode with Riley Black, author of The Last Days of the Dinosaurs. You can go through this podcast feed to find that. But basically, yes, an asteroid wipes out all of the dinosaurs, many mammals, but not all. And the mammals arise afterward to take on the many varied forms that we know and love today. So my question here, talking about these mass extinctions and in particular the asteroid, is that when you're researching these things, it's kind of a more personal question. When you're researching these things, that took out so many different animals, is there an emotional element? Does part of you feel bad or wish you could have stopped it? Or on the other hand, are you kind of just more grateful that this happened and, got dinosaurs out of the way so that you and I and all our big mammal friends could evolve?
Well, there definitely is that. We would not be having this conversation if that asteroid never hit, because dinosaurs had been dominant for over 150 million years. They were living all over the world. There were big ones and small ones. Okay, none of them were mammal size, so there weren't tiny ones, but there were, things. There were long-necked dinosaurs the size of airplanes, and tyrannosaurs the size of buses, all the way down to raptor dinosaurs the size of small dogs. Great diversity. Meat eaters, plant eaters, all kinds of behaviors and ways of moving and ways of feeding and so on. And that's what the world was like when that asteroid hit. And I mean, it was literally just one day this asteroid fell from the sky. The dinosaurs would have had no inclination that this was coming. And so, what a bad luck. Let's just say, how bad can your luck get? This is bad luck on an absolutely cosmic scale. And so if that asteroid never hit, if it sailed right on by, if it just rustled the upper layers of the atmosphere and went on its way, surely the dinosaurs would have survived, they would have endured, they would have continued to evolve, continued to diversify, continued to adapt, and mammals probably would have stayed small. So we would probably not have had our chance to evolve, and we wouldn't be having this conversation. So in that sense, yes, of course, I'm grateful for the asteroid. But it is kind of sad when you research these things and when you find fossils of these animals and you get a sense of just the death and the destruction that happened during these extinctions. And these mass extinctions, they've happened throughout the history of life. There have been different causes. Sometimes it's volcanoes causing global warming, other times it's asteroids, other times it's been ice ages. But these extinctions are really valuable to study because these extinctions, they tell us about what happens when real plants, real animals, real ecosystems actually are faced with real moments of climate and environmental change. So they're valuable. That's why fossils are valuable. That's why fossil mammals are valuable. Our ancestors have been through so much, and we can learn a lot about our current world. We can prepare better for the changes happening today by studying our fossil ancestors.
Mm-hmm. Well, let me follow up on that. You can talk about either the extinction of the dinosaurs or any of the other episodes of rapid warming or cooling or ice ages that mammals have dealt with in the years since. But what are some of the lessons we can take about, which mammals have survived, which didn't, how mammals adapt to changing climates or environments that might be useful when looking at our current situation?
There are so many lessons from the fossil record. There's so much we can learn. This is what I encourage people. The world today is changing very fast. Temperatures are getting hotter and hotter. Sea levels are rising. There's other changes. All these things have happened before. Okay, this is not the first time the Earth is getting warmer. This is the first time it's happening because of human influence. But in the past, there have been many episodes of global warming. We can look at the fossil record to see what actually happened during those times. I think that's lost a lot of times. And when we talk about global warming, we talk about climate change. So first of all, just at the most fundamental level, the fossil record gives us perspective and it gives us insight into real changes that have happened in the past. When it comes to mammals, there's a lot of lessons to draw. The first thing I'll say is mammals are resilient. Mammals have been through so much. Again, we've had these ancestors who've got through 3 mass extinctions. And over the last 66 million years since the asteroid, there have been episodes of global warming, there have been episodes of cooling, there's been even an ice age, there's been plenty of volcanoes. Mammals have gotten through it all. So first of all, mammals are resilient. I think we should take solace in that and take some pride in that too as a mammal. Secondly, from a more specific standpoint, there was a global warming episode about 55 million years ago, 55, 56 million years ago. It was the hottest the Earth has been since the asteroid that killed the dinosaurs. And the temperature spiked by something like 8 degrees Celsius in a few tens of thousands of years. This was a really intense amount of global warming, although it's happening faster today. But this was a really tough moment. Climates got really, really, really hot. And so what did mammals do? Well, we can look in the fossil record. There's a great fossil record of mammals. And we can see, first of all, that there were not a huge number of extinctions. It's not just like a bunch of mammals died. So that's kind of a good lesson. But mammals moved around. There was a period of mass migration. And mammals that came from other places often swamped local ecosystems. So there was a big changes going on in the community of mammals. Even though it wasn't a big extinction, there were big changes, and a lot of immigrant species, immigrant mammals moved around. Secondly, it led to a bit of a changing of the guard. The mammals that were dominant before which were a lot of these primitive placental mammals, early cousins of ours that gave live birth to well-developed young, and the mothers had big placentas like we do, early members of the placental group. They were the dominant ones in the Paleocene period after the asteroid. Then this global warming hit, and those animals went into decline, and it was more modern mammals, things like horses and cattle and bats and whales and elephants and primates and so on, that really seized a lot of the roles in ecosystems. So there was a changing of the guard, and the mammals that were dominant, they were swept away, basically. They didn't go totally extinct, but they were nowhere near as important as they were before that global warming. And then third, we see a lot of mammals responded by getting smaller. Individual species of mammals got smaller over time as the Earth got warmer and warmer. And something like 40% of the mammals living then got smaller as the temperatures got higher. That's a common survival trick of mammals. So all of these things I've just mentioned, this gives us some perspective. These are things that actually happened to mammals in the past when there was a big sudden global warming episode. They are things that hopefully can inform our future, help us better understand what might happen to mammals, maybe even to ourselves as we go forward.
So you're talking about horses and primates and all these types of mammals that we know today, and some of them at least are larger than a badger. That means they did not exist before the asteroid hit the dinosaurs. Primates, at least early primates, might have existed before, but the recognizable animals that you're talking about, most of them did not. So how soon after the asteroid did these forms that we recognize start to evolve?
After the asteroid hit, some mammals survived. We had ancestors that stared down that asteroid and made it through. 75% of species died, but some mammals survived, and they survived because they were small, because they were adaptable, because they could burrow and hide and protect themselves, because they could grow fast and reproduce fast, because they could eat lots of different foods. So being small and having to endure so long underfoot of the dinosaurs, that primed mammals to get through this sudden and unexpected period of total global bedlam. Then on the other side, imagine you're one of these mammals. Now there's no T-Rexes anymore. There's no Triceratopses anymore. The world is open. The opportunities are abundant. And so what did mammals do? They diversified very quickly. And in particular, they started to get bigger and bigger. And whereas over the previous 150 million years, there was never a mammal bigger than a badger that lived with the dinosaur, now within 200 or 300,000 years after the asteroid, there were mammals the size of pigs. Within 1 or 2 million years, there were mammals the size of cows. And we find these fossils in places like New Mexico. I was just in New Mexico a couple of weeks ago doing field work with my students, with my colleagues, looking for the fossils of these mammals that were living within the first few 100,000 and up to the first few million years after the asteroid. So these mammals got bigger. They started to take control of ecosystems, but these mammals were kind of strange. A lot of them were obviously placental mammals, so again, they could give live birth to well-developed young, just like we can, and horses and bats and whales and elephants, and most of the mammals are placental mammals. So these Paleocene mammals living after the extinction, getting bigger, taking over ecosystems, they were placental mammals, but they don't obviously share features with horses or with bats or with elephants or whatever. So they're very hard to classify. We just call them archaic placentals because we just know so little about them. Then it really took that global warming episode about 55, 56 million years ago for some of these archaic placentals to give rise to more modern mammals that then took over the world, that migrated widely as the temperatures warmed. And so it's only about 55 or 56 million years ago, 10 million years after the asteroid, that we see the first obvious horses and cattle and primates in the fossil record. But once they show up, they just seem to materialize almost everywhere, at least up north were the best fossil records. In South America, in Africa, in Australia, these were all island continents stranded south of the equator, and there were very different mammals thriving there, things like marsupials that raise their tiny babies in pouches, even the monotremes, which today persist as a few species, but these are the mammals that still lay eggs, these very primitive mammals like the platypus and the echidna.
So yeah, these mammals are becoming extremely diverse and fascinating. In one chapter, you highlight bats, elephants, and whales as three types of mammals that have taken particularly extreme forms, flying or swimming or getting huge. Um, but it's, even beyond them, it's such a wide range of forms, from squirrels to hippos to tigers to us. And you've highlighted some of that earlier, but do you have personally any particularly favorite mammals?
I am fascinated by so many different types of mammals, but some of the mammals that stand out to me, at least in the fossil record, are the megafauna, these giant mammals that lived quite recently. They only went extinct quite recently. They lived during the Ice Age, and many of them died out just about 10,000 years ago. So our human ancestors, our Homo sapiens ancestors, would have seen and encountered and confronted and hunted a lot of these mammals. So I'm talking about things like woolly mammoths, saber-toothed tigers, but there were lots of other amazing megafauna. There were sloths that lived on the ground that were over 10 feet tall. There were armadillos the size of Volkswagens. There were beavers the size of humans. In Australia, there were wombats that weighed 3 tons. There were kangaroos that were too plump to hop. I mean, the megafauna was just spectacular, and it lived until so recently. There are caves in France and Spain that are plastered with paintings of mammoths on the cave walls. This is the earliest human graffiti. And so our own ancestors, members of our own species, knew these animals, and probably sadly were one of the main reasons why these animals died out.
Yeah, on the note of Ice Age megafauna, you mentioned in the endnotes that you wish you'd had more space to write about direwolves. So here's your
I do.
chance. What are direwolves, and why do you wish you could have written about them?
So direwolves are part of the megafauna in a sense. So they're similar in some ways to today's wolves, and they're somewhat closely related, although they're quite an archaic lineage of wolves. But I wish I could have said more about them. Because they're pretty famous, from Game of Thrones for the main reason. They're characters in Game of Thrones, and so the name dire wolf, it has some real cachet to it. There's also a lot of fossils of them, and for instance, the La Brea tar pits in Los Angeles, just smack in the middle of Los Angeles, close to Beverly Hills, is this amazing fossil site where megafauna mammals and other ice age mammals and other animals basically fell into tar. There was tar that was bubbling up because there's an oil field way under the ground, and this tar sometimes would capture animals. Animals would go in the tar looking for food or looking for water, or whatever, and they get stuck and they sadly die and they become fossilized. And one of the most common fossils there are dire wolves. There is an entire wall at the La Brea Tar Pits Museum, and I was just there a few weeks ago, and I loved it. This entire wall of dire wolf skulls. So there's just something about these animals. I mean, think like wolves on steroids. They had a cool name. They've become iconic in Game of Thrones. We have lots of their fossils. They would have been living in Los Angeles, 10,000 years ago. I wish I had more space to talk about them. They were kind of one of the last cuts when I had to make final edits and get the books down to size, sadly. But maybe that was not the right choice. I don't know.
So I was hoping you could walk us through a bit. You mentioned our primate ancestors really started spreading across the world during the Eocene period. That's that earlier period of heating you mentioned. And in the book, that goes on that some of those primates rafted on a fallen log or something across the ocean from Africa to South America, which is pretty wild. And keep that story going. Some of those primates stayed in Africa, became apes, became humans. Some of those humans spread across the world to, encounter the Ice Age megafauna you mentioned. Is that, can you walk us through that story?
The history of primates is fascinating, and the first primate ancestors go back to right soon after the extinction of the dinosaurs, and then about 10 million years later, true primates, proper primates, things that we can easily identify as primates, turn up as fossils. And from there, they started to diversify. And one of these groups of primates left Africa, so and then made its way over to South America, which is crazy because Africa back in the Paleocene and the Eocene periods was an island continent. But it was close enough to Europe and Asia that there were some land bridges, there were some islands that kind of linked the two. So some animals from the north could get down into Africa. That's what probably happened with primates. They originated somewhere up north in Europe or Asia or North America, and they hopped some islands and reached Africa. No big deal. A lot of animals did that. But then South America was also an island continent at the time. It was completely surrounded by water, and it was thousands of miles away from Africa. And somehow, some primates left Africa, made it over to South America, probably on rafts of vegetation that were maybe thrown off the coast of Africa during a storm, and just through the currents of the ocean wound up on South America. We don't know how exactly, but it must have been something like that because genetically, it is clear from the DNA that these monkeys that are still in South America today, they are nested within families of African monkeys. So some of these monkeys rafted across an ocean somehow, some way, and then others, of course, stayed in Africa, and they continued to evolve and diversify and adapt as climate changed. And from these animals came the apes. And from the apes ultimately came us. And it was about 5 million years ago or so, give or take, that the first humans appear in the fossil record. And by that I mean apes that walk upright, only on their legs, with big brains. This is the start of the human line. And for most of the last 5 or so million years, there have been multiple species of humans living together. Sometimes numerous species of humans living together, just like sometimes there are multiple species of hoofed mammals living together, or multiple species of carnivores living together, or multiple bats living together. The same used to be true with humans. And it's only been very recently, within the last 40,000 years or so, that we, Homo sapiens, have stood alone because we had close relatives, different species, but close relatives that we encountered, and we probably fought with them, but we also interbred with them. And so by about 40,000 years ago, those other species were no more, leaving just us, Homo sapiens, all alone to contemplate where we came from.
Yeah, that's just an incredible story to me. But to bridge the gap between primates and your earlier passion, dinosaurs, you are also the science advisor for the recent Jurassic World movies. The newest one just came out recently, Jurassic World Dominion. So you talk about in the Mammal book that some people are discussing, debating whether to, try to revive mammoths, bring back mammoths from extinction. What if some billionaire scientist reached out to you and said, hey, I got this island and we're trying to revive the dinosaurs, but we need your help. We need a paleontologist on board. What do you say?
Well, I took a job when the movie producers came calling, when Colin Trevorrow, the director, and he read my book on dinosaurs and got in touch with me. I thought it was a fake when he sent me his email, but turned out to be him. I met up with him, and he told me he wanted to get a lot of new dinosaurs in a new film and put some feathers on the dinosaurs and wanted my help in doing it. And I was just overjoyed to play a role. So I did that. I took the bait there. I've loved every moment of it, just helping to work behind the scenes, making sure the real science is always in the ears of the director, the writers, the artists, the people making the real magic, the real Hollywood magic. So now if there was some mad billionaire in real life, if Elon Musk or Jeff Bezos or Bill Gates or somebody said, hey, I'm building a dinosaur theme park, don't tell anybody, you want to come and help out, I would definitely have very conflicted thoughts about that, because as much as I would love to see real dinosaurs, I mean, I study dinosaur bones, I'd love to know what these bones were like as actual animals that had to move and grow and feed and reproduce and socialize and so on. I'd love to know that. But dinosaurs lived so long ago. The world was so different back then. The atmosphere was different. The plants were different. The climate was different. It was much hotter back then. So if you brought dinosaurs back into the world today, really you'd be basically like plonking a human onto Mars. You'd be putting an alien species onto the Earth. So I would be very conflicted ethically if something like that were to ever become possible.
Yeah, I think that's one of the strong points in the Jurassic World movies is that there's sort of an ethical interest in the well-being of these dinosaurs as individuals. Um, so yeah, I know you don't have too much time left. I have two more sciencey questions about Jurassic World, and you can either answer both or take one or leave one. But the first is about the dinosaurs' intelligence. So throughout the trilogy, there's this ongoing, rocky but seemingly genuine friendship or relationship between Chris Pratt's character and a raptor named Blue. How smart and social do we think raptors and some of these dinosaurs were? And like how plausible would a relationship like that be? Um, and then secondly, is about the feathers. This is the first, to my knowledge, Jurassic Park or World movie where some of the dinosaurs have feathers. They look great. It was fun, and I know that sort of the research into dinosaur feathers is something you're interested in. You've written about before, so yeah, you can, like I said, take one or both of those questions: feathers and intelligence.
Yeah, I'll start with the feathers and say a few words about intelligence before we wrap up. So feathers, I'm so happy we have dinosaurs with feathers in the new Jurassic World. This is something that a lot of paleontologists have been wanting for a long time because we know a lot of dinosaurs really had feathers. Some even had wings. The problem is the first fossils of dinosaur skeletons covered in feathers were not discovered until 1996, which was 3 years after the first Jurassic Park came out. So the timing was just terrible. Spielberg never knew dinosaurs had feathers. But since then, we found thousands of fossils of these feathered covered dinosaurs. So it's been unfortunate that they haven't made it into the Jurassic Park, Jurassic World universe, but finally they have. And this was Colin Trevorrow's vision from the start. When I first met him, when he came to Edinburgh, to talk dinosaurs with me, he said, "Look, I want to put feathers on some of these dinosaurs. I want to do it. I want to do it right. I want you to help me to do it." And I jumped at that opportunity, and it was a lot of fun. There's some amazing new characters: Pyroraptor, Therizinosaurus, Moros. These are three dinosaurs you'll see in the film with different types of feathers, and I think they're all very engaging characters. When it comes to brains, we can actually study the brains of fossils at a distinct species, not because we find fossilized brains, but because we can take the skulls of dinosaurs, let's say, and put them in a CAT scanner and use the x-rays of the CAT scanner to see inside those skulls, just like a medical doctor would with a CAT scan of us. And we can then use software to build digital three-dimensional models of the brain by filling in the space in the brain cavity. So that tells us how big the brain was and what shape it was. And what that, more than anything, tells us with dinosaurs is some dinosaurs, like the raptor dinosaurs, were very, very smart. And their brains, in relation to their body sizes, were probably getting into the zone of mammals. So we know mammals are smart. We are a mammal. We know we're smart. Our other mammals are smart, but a lot of dinosaurs would have been pretty smart.
Thank you for that. Yeah, the movie is Jurassic World Dominion, and the book is The Rise and Reign of the Mammals. It ends on kind of a forward-looking note of mammals are once again facing not yet a mass extinction event, but potentially one if things continue apace. So, yeah, it's important to learn about our mammal history, what we've been through before, and what we might go through next. So, is there anything either about those dangers mammals are facing, or anything else you want to add before we go?
Well, I'll just close by saying, in The Rise and Reign of the Mammals, the new book, I have an epilogue that talks about the modern day. And I try to keep it short and I try to keep it factual. I don't try to veer into too much speculation. Certainly, I'm not veering into alarmism or any real doom and gloom. I just lay out the facts. The facts are that this is the most perilous time in the history of mammals since they stared down the asteroid, since our ancestors had to deal with that asteroid. About 350 mammal species have gone extinct since Homo sapiens started moving around the world. And there's a lot of endangered mammals, and if we lose all of those mammals that are currently endangered, we might lose something like half of mammalian diversity within the next few centuries. So those are sobering numbers to think about. However, mammals have proven resilient over time. All the things mammals survive, all the extinctions and the global warming episodes and the ice ages and volcanoes and all these things mammals have survived. And secondly, we have evolved. A single species, but a sublime species of mammal with big brains and consciousness and the ability to work together in groups. We have this ability to shape the earth both in bad and in good. So by learning from the fossil record, learning from our ancestry, in addition to all the other scientific advancements that we're making now, I am confident that we will find a way to mitigate our worst effects on the environment. So I am hopeful, but I'll end it there and just say thank you very much, Dayton. It was a great conversation, and hope some of you may be interested in reading The Rise and Reign of the Mammals.
Yeah, thanks so much. It was fun, and I enjoyed the book.
All right, thank you very much.
That was Steve Brusatte, author of The Rise and Reign of the Mammals, A New History from the Shadow of the Dinosaurs to Us. Thanks so much for listening. If you like that episode, please rate this podcast, review it, follow it, share it with a friend. I'd also really appreciate if you are able to financially support this podcast. That will allow me both to spend more time on it and also, potentially get new audio software, microphone, help improve some of the audio. And yeah, if you want to engage at all, you can follow me on Twitter or follow this podcast on Facebook. Those links are in the episode description. Patreon supporters can also ask me questions if you ask me a question on Twitter, I'll answer, but ask me questions that I might do a longer answer or deeper dive to figure out. So whether you have questions about follow-ups from this interview or the Jurassic World movies or anything else related to climate, ecology, animal justice, yes, please follow this podcast on Patreon. Also, please consider subscribing to my free weekly newsletter. Also, please consider having a great day today. Thanks.